An AHI or ODI value can look precise while resting on an incomplete night, a loose probe, movement artifact, or weak peripheral signal. That is the central risk in wearable sleep screening. Treating a summary metric as a conclusion before checking whether the recording can support it. AHI estimates how frequently breathing interruptions and partial interruptions occurred during sleep. In laboratory testing, event scoring draws on multiple physiological channels and established review procedures. A wearable monitor may infer related events from fewer signals. Its AHI can identify patterns that merit follow-up, but it remains screening evidence rather than a self-explanatory diagnosis. ODI summarizes detected decreases in oxygen saturation during the monitoring period. It adds context to the overnight SpO2 trend, especially when repeated dips are hidden by an unremarkable average. But ODI does not establish the cause of each dip. Motion, poor sensor contact, peripheral circulation, respiratory events, and other clinical factors may influence the pattern. A disciplined review begins with recording duration and completeness. Confirm that the session was long enough for its intended purpose and identify gaps, early removal, or interruptions. Then examine signal quality before reading the headline scores. Low perfusion periods, movement artifacts, loose probe warnings, and unreliable intervals can materially change what the monitor was able to detect. Next, read AHI and ODI together with the SpO2 trace. Look at the timing and repeatability of oxygen changes, not just the totals. Perfusion index can provide supporting context about pulse signal strength, while sleep stage classification should be treated as device-dependent and reviewed against the algorithm, intended use, and available validation evidence. The fourth step is to compare the recorded pattern with the patient pathway. Symptoms, risk factors, previous results, and the reason for screening determine whether the appropriate response is continued monitoring, another recording, referral, or broader assessment. Differences between nights can reflect sleep position, sensor fit, movement, circulation, illness, alcohol use, medication, or recording duration. Finally, document both the next action and any remaining evidence gap. The record should state whether the study was adequate, which values and traces were reviewed, and why a repeat capture, referral, or no immediate action was selected. Repeat monitoring is most useful when triggers are defined in advance, such as early device removal, interrupted transfer, prolonged low signal, or a result that conflicts with symptoms and history. These same 5 steps provide a practical test for procurement. A useful system should expose missing data and low-quality intervals, show event timing, preserve repeat session history, and support clear report status. During a demonstration, buyers should ask to review an imperfect recording rather than only a polished final score. The BM2000A85 wrist pulse oximeter is presented with SpO2, pulse rate, perfusion index, AHI, ODI, sleep stage classification, app-based analysis, an online platform, and remote monitoring capabilities. Those listed functions are starting points, not proof that every configuration supports the same workflow. Exact model, firmware, accessories, communication options, software version, and intended use require confirmation. Model-specific instructions, regulatory documentation, validation evidence, report examples, export functions, access controls, privacy arrangements, support procedures, and transfer failure handling should all be verified. Company-level credentials do not automatically establish model-level performance or certification. A pilot should test comfort, overnight retention, charging, transfer reliability, report clarity, and reviewer workload under realistic conditions. Wearable pulse oximetry, home sleep testing, and polysomnography serve different purposes. Wearables offer convenient overnight trend capture but use limited physiological channels. Home testing provides broader respiratory data with more setup, while polysomnography delivers comprehensive supervised measurement at greater operational burden. The correct choice depends on the clinical decision being supported. AHI and ODI become useful when they sit inside a visible evidence chain. What was measured, how complete the night was, where signal quality failed, and what happens next. Without that context, a precise score can create false certainty. With it, wearable monitoring can support a structured, auditable screening pathway.